Lusa, Chala, Hinduja, Hinduja, Smart, and Samart, not smart, Samart, Alak, Jia Feng,
Yeah.
Anita, Rajendra,
Yes.
Yu Hao,
Yeah.
Krishan, and Kriti, Tanvin, Pasanti, Ming,
Yeah.
Rigard, Sai Panit, Abhinav, see you, right? So I think that you need to check. So you are in the undergraduate program. What's your major?
Computer science.
BS, CS,
BS.
MS or BS?
BS.
BS. So you need to register the 3 OA. Okay.
Yes.
And Shreya
Yes.
and Jagriti, okay. Mega, Prachi, Pata, Sai Kishore, and Shamir, Sai, Aditya, Anurag, Joseph, Soumya, Lokesh, Chang, okay, so for the rest of the semester, most of the time your attendance will be checked by the pop-up quiz. I do not know when and what time, so but for the pop-up quiz you don't have to be serious, okay, it's just a very, very basic question. So what is the 1 plus 1, like that, okay, so you don't have to be prepared, just if you are attending or if you read the textbook, you are able to answer. And also I'm going to use the Kahoot. So this is the elementary level, the quiz, the program. So it's very basic, there is no number, just the touch, the color, that is correct. So I'm going to show when we have the first, the pop-up quiz, you don't have to be prepare anything, okay? Then we have the 11, so we have a time. So, I'm sorry, who are taking the database as well as the operating system, it will be very similar to this question. Anyway, so we are dealing with the computer. So this is what?
Computer.
So this is a rectangle, but in my class, this one means computer or server. So I'd like to start what is the basic subject core course of our program, MS, CS, and C. So OP is a programming. What program language is it? C++. And the OP and the C, we have computer architecture. And the CS, we have algorithm. And the DCC is a network. Is it for the computer engineering also?
Yes.
So both of them. And we have OS and database. Pretty much 5 of them as are core courses. Unfortunately, I'm teaching the 2 of core courses. Actually, only the database, but recently I'm teaching the operating system also. So, these are the basic subjects that you need to complete to get the degree. But anyway, so all of these are dealing with the computer related stuff. So we are talking about the computer science. Please understand me. It's the time to sleep. The 24 hours ago. So usually when before I come to the class, I prepare the kind of a plan what we are going to discuss. But it's a little bit messed up the database course and the operating system today. So I talk about more about the operating system stuff in the database class. So a little bit, please understand me, but only today. It will be better than next. So these are the core courses. So I usually focus on the importance of, there are common things in these 5 subjects, and plus elective course also. So all of these, and including the elective course, in our major, we are talking about the computer and the computer-related stuff. That's true because our major is computer science or the computer engineering. I don't think I can see the non-computer science major. Then, what is the main part of what is the common thing of all of this? Computer. And computer is not very smart like you. You are very smart. So you are the selected person. Think about in worldwide, how many of them are taking the graduate level courses? Not many, only few of them. So you are selected, the person. Then, anyway, so among this, what is the common thing of this? Throughout the semester, I'm going to mention about the importance of data structure. So computer is not this smart. Computer can understand only actually 0 or 1, combination of the 0 or 1. That is true because computer is the electronic device that can compute something. Something means for example, instruction or the data and the whatever, but they are based on the 0 or 1. There are other types of computing nowadays, like the quantum computing and so on, or biocomputing. So they are not based on the 0 or 1, but still most of the computer and the computer architecture are dealing with the 0 or 1 because due to the characteristic of the computer, it's an electronic device. Electronic means electricity. Electric can represent only 0 or 1, the signal. So turn it on, turn it off, like that. But how to use the 0 or 1 for the graphic, for the gaming, for the data analytics, or something other, any complicated stuff. Because we can organize the huge number of the 0 or 1 meaningfully. So that meaningful organization is called the data structure. So because of that, so if you go back to the freshman or the sophomore, you took the basic data structure class and the advanced data structure classes. Those are the most important part. That differentiate from the electrical engineering. That differentiate from the mechanical engineering, other engineering, other the subject. So this is the most important part of the any subject in computer science, especially in operating system. So, for example, the OP, deal with the program language, is for the communication, and the computer architecture and the algorithm. Computer architecture. So, before computer algorithm. Algorithm. What is the algorithm? What did you learn in your algorithm class? So, bigger notation and time complexity and density for what? Algorithm. Okay, there are a bunch of algorithms you learn, and there is a logic, and they are just your imagination. No, it's a word structure, rules, and the logic. So that is also data structure and the data communication. So when we communicate, when you send the data, when you receive the data, it should be formatted very clearly. So what is a packet? So there is a size of packet. Packet has a header. The first 10 bytes used for this one and this one. So it should be structured, the information. And then the architecture, computer architecture to deal with the communication and the algorithm to process data. So computer should follow the certain structure. The hardware level is a structure. Okay, like the CPU follow the define the several instruction that you have learned in your microprocessor class. It's also structure. And the database, we don't have to mention about the importance of the data structure in the database. It's everything. Okay. Then what about the operating system? What is the operating system? What kind of operating system have you ever used? Windows. Windows 3.1. Anyone who ever used the 3.1? Oh, really?
Yes.
Oh, wow.
Just try it.
It's my...
I tried it.
You try? Just for fun? So, 1992, I was in the military. In my hometown, the military service is compulsory. I should serve for the military for 2.5 years at the time, the 30 months. So which means that during the 30 months, I cannot go to my home and just the military camp I should stay. Only the 30 days, the vacation during that time. But so in that, the military camp, they actually brought the first time the computer, Windows 3.1. So I used the Apple computer before, whether or not you know, it's the old side, the Apple computer. And also I used the IBM XT and AT, it's a green CRT monitor. But in 1992, in the military camp, they brought one computer which is Windows 3.1. It's really Windows, the box. It's really new word. And has been upgraded and developed, and right now it's a 10, so Windows. And what else? Mac OS. So that's also my old experience. So in 1995, actually, I have a chance to visit my elder sister who lives in Hawaii. So I stayed at the University of Hawaii for 6 months. So I stayed in the dormitory. Then my roommate, his major was the computer science, and he had the Mac OS. So it's Aqua the OS, Aqua the interface. Then it's totally different from this one. It's more pastel tone and fancy, nice the graphical user interface. Then what he did, the only thing he did during that time is SimCity. He played every night, every day, to play only the SimCity. So it's but the Mac OS still use the Mac OS. So But this is based on also the BSD, the Unix. So we have the Unix and the Linux. We will see the difference later more. And there are many other operating systems. Okay, so these are the operating systems. Then, what are they? Why do you need the operating system? This is a what? Computer. It's a hardware. So I'd like to use this hardware for what? Gaming, or the communicating, or the processing the data. I'd like to use this. But this is just hardware. Without power, then there's nothing. So even though there's a power, what happens? So it's nothing. You need to have something in between this one and the user. Okay, hardware and the user. So that is the hardware. No, the hardware is already here. That is the user. No, it's the in between the user and the hardware. It's the software. So that is this kind of operating system. It's a software, just like the application program that you develop. So if you already took these classes, in most of the classes has the programming assignment. After you compile, you have the executable file. So that is the software. That is the application program. So that's the same as this operating system, but different purpose. Okay. So only one the program? No, there are a lot of things inside. So it has the package of the software, a lot of software. So by grouping, we call this set of the software as the operating system. In this class, we are going to discuss about what are they and what kind of each of them. To understand this, definitely we need to understand user need. Okay, and also we need to understand this one, the computer. So before we start the topic of the operating system, we try to briefly review what is a computer, and then we will understand what we are going to learn in this semester. Okay, so as you probably know, computer has several important parts. The first one is the CPU. So we are not going to discuss the details about the CPU in this class. Mostly, we are not going to discuss about the details of the hardware and computer architecture. However, without understanding the computer architecture, it's not easy to understand the operating system, because the operating system itself needs to use the computer architecture. So it's very important to understand the computing architecture. Okay. So, but today we are going to briefly see how the computer is working. So CPU. What is a CPU? It's a processing unit. Processing what?
Data.
Data. What kind of data? Actually, it can process only the instruction. So this is a computer device. It's a chip. It's a main chip that usually processes something unit. Process what? It's something data, but different types of data. When the manufacturer of this CPU, like the Intel, AMD, they design this CPU can process the addition. The processor can process the minus. This process can move the data. And this process can shift the binary, shift up, shift down, then define a number of operations. This is a fixed, and these are the set of instructions provided by the CPU. Then using this instruction, you can do the program using move the value to the register 1 and move the value register 2 and add the register 1 and register 2 and save to the register 2 and so on. So you can do the programming. This is called the assembly programming. So assembly programming is the basic program language that can be used by the CPU. Because of that reason, in the microprocessor class, you learn some assembly language. Okay? Problem? Not easy. Okay? It's very hard to directly code. There are someone who can directly code the assembly language, not me. So it's the low-level languages, so we need to use the high-level languages, like the C, C++, and the Python, Java, any other program language that you are using, whether you know. So those are considered the high-level languages. So problem is a high-level. Computer cannot understand this. So we need to compile to this one. So when we compile the high-level language, it will create the executable file, exe file, sometimes executable file. So executable file consists of what? This set of instructions. Then they will be stored at the secondary storage, hard disk drive, or nowadays we use the SSD, solid state disk. So that file system, like the NTFS or FNT32 and EXT, the 0 and the 2, 3, 8, and so on. So for UFS, there are many different types of the file system. So in the file system, this executable file will be stored. Unfortunately, CPU cannot directly access such an executable file because this one is fast, this one is slow, huge speed gap. How much fast? For example, 3.2 GHz, the CPU clock speed means what? How 3.6 gigahertz times the cycle is a frequency. And usually we need 2 or 3 cycles to process one instruction. Let's say the 2. Okay? How many instructions? 1.8 gigahertz number of the instruction can be processed 1 second. What about this one? Nowadays, the solid state disk is faster than the hard disk drive, but still it's much slower than this. So, because of the speed gap, the CPU cannot directly access the data. Instead, we are using the memory. So, memory is called primary storage. So, some of the students confuse the primary storage is this one. No. Primary storage is from the CPU point of view. CPU is the most important part. It's like the brain of the human being. So it's from this point of view, this is a primary storage. So we need to upload this set of instructions to the memory. Okay? So this is called what? Creating process. And finally, if we copy all of this instruction, not all actually, but if we copy, let's say, such an instruction to the memory, then the CPU is ready to access this one. Then process each instruction. So that is how it works when you use the computing power. The problem is this. Creating process. So this is the only way to use the computing power, including operating system itself. Do you remember the operating system is also software? It's actually same as your application program. If you compile A.C file, so A.out, this is your executable file, but actually this is the same as it's a part of the operating system. So operating system is also such an executable file, which means it should be in memory, it should be the processes. So number of processes, think about when you start up your operating system, what happened? Actually, creating number of processes. Because of that, it takes a time to start your operating system. Why it takes a long time? Because your system should load, create a lot of processes. Creating process means what? We need
Bringing in the memory.
bringing the memory. Just to put all the instruction. Not that simple. We need to follow the rule. Okay? At that time, actually, before we discuss about that detail, what is a memory? Memory is nothing but sequence of address. It's an address. Everything is address. So when you learn the object-oriented programming, what is the most difficult part? It's the reference. Okay? Whether you understand the reference or not. That is the same problem when you learn any program language actually. So if you already learned the C or the C++, especially C program, what is the most difficult part of the C program? Pointer. Okay? If you understand pointer, everything is done in the C program. So most of the students who give up the learning the C program is because of the pointer. What is a pointer? Pointer is the address. So in the memory, so actually there's no string type in the C program. Instead, we are using the array of the character, C, the primitive data type. Actually, which means the low-level programming language has only such a primitive type. By combining number of such a primitive data type character, then we can represent the string. Then, at that time, we consider such a set of the character. In other words, the array as the pointer address. Because of that, if we have the two-dimensional array, it will be more complicated. So we need to understand such a pointer. To address that problem, instead of the pointer, we are going to use the reference in the object-oriented concept. When we instantiate, when we create the object using the class, it will return the address. Using that address, we are able to. Still, without that is the reason. So understanding memory structure itself is very important to know, to understand how your program is working. Okay? Especially the memory structure. It's the data structure also. Okay? So, going back to the creating process, to use the CPU power. So we already code this one. So we create a sequence of instruction. Then, to be able to access the instruction from the CPU, we need to load such an instruction into the memory. Just to put everything to the memory, we need to follow the addressing format. Okay? Then this addressing format is specified by the CPU. So CPU has if you go back to your microprocessor class, so you probably learn not the microprocessor, compiler class. So if I don't think you'll be offered the compiler class. I don't think so. But if you are taking the compiler class, what compiler class is doing is actually not just converting the high-level language into the low-level language itself. It's not complicated. You can just match. The more important thing is how to organize the instruction into the memory. Which means, so like this part is for the instruction, this part is a global variable, this part is for the dynamic increase the data like the array, and this part is a temporary data. It's very specifically the design, the address of each data. Based on what? For each CPU. Because the CPU will use this. If CPU does not know the format, no way to access. Okay? So when you design the compiler program language, you need to follow such a specific rule. It's a data structure. It's a process data structure. Then by following this rule, when we create the process, we can the upload, the instruction plus any other information by finding this structure, and the final CPU know the disk. You cannot just copy everywhere. The then CPU does not know. You need to just follow it. So this creating process is the most important part of your operating system. So we are going to spend almost half of the semester regarding to that creating process part. Okay. Then, how many processes? Number of processes. Long time ago, when we are using old, like MS-DOS is another operating system. Have you ever used MS-DOS? If you are using old version of Windows, it's part of. Actually, the main problem of the old version of Windows, when Bill Gates developed his own Windows operating system, it started from the MS-DOS. MS-DOS is a simple operating system. It can create only one process at a time. Then, on top of that, he created the graphical user interface, so Windows operating system. Actually, there are two operating systems within one umbrella. Okay, so that is a problem. They are fighting. They conflict. So each of them will try to access the hardware. So it is a huge problem. Later, the Windows actually throw away such a MS-DOS part and keep the Windows. The problem, their Windows the operating system, it's not actually in terms of architecture, it's not perfect. Later, recently, the Windows actually adapt the shell, the programming, the shell, as well, like the cone shell, the bash shell is available in the Windows. So we will see the more detail. But the MS-DOS is a single process operating system. But after that, most of the operating system that we have has the multiple process, which means you can create as many. Forever? No, it's limited. One of the main problem of the memory is a limited resource. So the size of the storage, primary storage, is much less than the secondary storage. So we cannot create as many processes as possible. Instead, we need to manage this one. So that is the second part of the operating system, memory management. So we are going to spend half of the semester regarding to the process. And a little bit about the memory management. Then last part is this one. So we have the three main components plus I/O devices. Then mostly, this one actually any device that are connected to the bus in the motherboard are considered as the I/O devices. CPU is also I/O device, input and output after processing. Memory is definitely I/O device. You can request the data using the addressing, the memory address, and return. And the hard disk drive, the SSD file system is the I/O device. Mouse, the screen, anything can be considered as the I/O devices. Most popular I/O device, as you know, is the file system. So